Hey guys, welcome to week 2 of online school. I gotta say, I'm very disappointed because I had a special guest teacher come in and I recorded a bunch of videos, and for some reason the files got all screwed up and corrupted. So, you gotta deal with me again, okay? Couple things before we get started the actual lesson. So, you've probably heard by now that Governor Inslee has decided that we're not going back to school at all this year, which makes me super sad because I miss you guys and I want to see you. So that's the bad news, or maybe good news if you hate school. The good news, though, is that, well, sort of good news, is that we've decided to go with a pass-fail grade for the year. And we're also almost for sure, I don't want to say for sure in case we change our minds, but you're probably not going to have any tests for the rest of the year. So what that really means is all you need to do is to participate, and you're going to pass second semester. So that's nice for you guys, okay? So there's no excuse for not passing this year. Get in there, do the work. It's not that much work every week. You do a little bit of math every week, and then you don't have to repeat algebra next year, okay? So do the work and encourage your friends that are in class to do it too, okay? Because we all need to get it done so that we can all pass, because I don't want 60 kids in my Algebra 1 classes next year. Okay? Let's do some learning. What we're going to cover today is graphing rational functions. As you can see, we already kind of learned how to graph the basic one, so we'll review that just to make sure you remember how to do it, and then we are going to look at rewriting rational functions in a form that we know how to graph. So that'll make sense when we get to it, okay? So a couple reminders. We're going to graph this function first, okay? Remember, rational functions, it's some number divided by x. Okay, this is our a. On this one, it's just 1. So the important points you have to remember are over 1 up 1, over 2 up a half, over half up 2, and then we have the same thing on the negative side as well. Okay, so those are our 6 important points. Okay, there's kind of only 3 of them, and then you just repeat them with negatives. Okay, so notice we can't put 0 in for x here, because if we put 0 in for x, the denominator would be equal to 0, and we can't divide by 0. So what that means is we have an asymptote right there. Okay, remember, an asymptote is the number that it gets really, 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 really close to, but never quite makes it to. So when we're graphing it, we should make sure that our graph never crosses that line. Okay. We also actually have an asymptote at y equals 0 because no matter what number we put in for x, we're never going to get 0. If we put 400 trillion in there for x, 1 over 400 trillion is a really, 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 really small number, but it's not quite 0. Okay, so those are our 2 asymptotes. This one doesn't have any stretches or shrinks or anything, so we're just going to graph these numbers. Okay, so from the origin there we go over half up 2, over 1 up 1, over 2 up a half. So this side looks like that. Okay, and then we go negative 1, negative 1, negative 1 half 2, negative 2, 1 half. So this side looks like that. Okay, remember, that's what these graphs look like. Remember, also, they should always be 2 opposite quadrants. You should never have like these 2 or these 2 or these 2. They should always be opposite. So they're either going to be in quadrant 1 and 3 or in 2 and 4 if there's a reflection. Okay, so that's what the parent function looks like. Let's try this one. It's just a little bit different. Anybody see any transformations on this one? Yeah. Yeah, good. Reflection over the x-axis. How'd you know there was a reflection over the x-axis? Good. I don't know if you guys could hear Benito there. He said it was because of the negative sign. And then what's the one other transformation? Xavier? Yeah, good. Vertical stretch of 6. Nice job, Xavier. Okay? There's no horizontal shifts, no vertical shifts. It's just a reflection and a stretch. What that means is that our asymptotes are going to be the same. So we still have an asymptote at the x-axis, asymptote at the y-axis, and we're going to take these numbers And since our a equals -6, we're going to multiply all the y values by -6. So instead of going over half up to, 2 times -6 is -12. So we're going to go over a half, down 12. Instead of going over 1 up 1, we're going to go over 1 down 6. 1, 2, 3, 4, 5, 6. And then instead of going over 2 down or up a half, half of -6 is -3. So we'll go over 2 down 3. So our graph looks like that. And then on the other side, -1 times 6 is +6. So we're going to go over 1, up 6, over 2, up 3, and over a half, up 12. Right there. So there's our graph. Okay, so notice instead of being in quadrants 1 and 3, since we had the reflection, it flipped over to 4 and 2. Another interesting thing about rational functions is you could also flip it this way and it would do the exact same thing, right? Instead of being here, it would flip over this way. So rational functions are weird because the reflections, it almost doesn't matter if you say x-axis or y-axis. And the other thing you'll notice, since we have that stretch of 6, is the graph is way further away from the origin here. On when it was just the first one, it was like super close to the origin. This one, since it has a stretch, it got further out. Okay, those two are pretty easy. Let's try one more here. Okay, let's see. Y equals -4 x plus 2 minus 1. Okay, I'm going to switch pens because I don't like this red pen. What kind of transformations do we see on this one? Well, we got a reflection, right? Over the x-axis. It's got a stretch of 4. And then it also is shifted 2 to the left and down 1. Okay, so what that does, we're going to do the shifts first. Alright, I zoomed in a little bit there so we can see better. Alright, so we did the shifts. We're going to do the shifts first, okay? Normally our asymptotes are the y-axis and the x-axis. But notice this one is shifted 2 to the left, right? So we're going to take this asymptote and move it 2 to the left. So I'm going to put a dashed line through -2. Okay, and then normally our other asymptote is the x-axis, but notice we move down 1. So I'm going to take this line and move it down 1. Okay? So we have here a new origin, basically. Instead of starting everything from right here, we're going to start everything from right here. And then once we move those asymptotes, we're going to ignore this stuff and just do this part. Okay? So our a was -4, so we're going to multiply all these y values by -4. So instead of 1/2 2, 2 times -4 is -8. So it's going to be from the new origin, I'm going to go over 1, down 8. Okay? Instead of over 1, up 1, from the new origin, I'm going to go over 1, down 4. And then half of -4 is -2. So from the new origin, I'm going to go over 2, down 2. Notice I never cross my asymptote, right? It gets really, really close to those, but never crosses them. And then we're going to do the same thing with the negatives. -1 times -4 is +4. So from the new origin, I'm going to go -1, up 4. And then I'm going to go -1/2 up 8, and then -2, and -1/2 times -4 is +2. Okay, so when you get shifts, just move the asymptotes, do that first, and then after you move them both, you just take these numbers and multiply the y values by -4. Okay, that's all the stuff that you should have learned last time. Or before the Rona took over anyway. Okay, so let's look at a few other ones. This is where it's going to get tricky, okay? Let's try this one. Okay, what kind of transformations do you see on that one? I mean, we could maybe think that it's shifted one to the left, maybe. But it's not in the right form, right? Normally we're used to some number over the x plus 1. So we need to rewrite this so that it will look like what we're used to before we graph it. Okay? There's two different ways to rewrite these. The first one I'm going to show you, last time we did it in chapter 4, you hated it. And then the second one I'll show you takes a little getting used to, but once you get used to it, it's actually probably a little bit easier maybe. Okay, so the first way I'm going to show you how to rewrite these is polynomial division. Remember that? It's the best. You guys loved it. So I'm going to do x plus 1 goes into 3x plus 5. The nice thing about these polynomial divisions is they're easy problems. You're not going to have like x squareds into x to the fourth or anything. Okay? So we'll just look at the x's. How many times does x go into 3x? Well, it goes in there 3 times. So then I multiply. So I got 3 times x is 3x. 3 times 1 is 3. And then I need to subtract this whole thing from that whole thing. Okay? Remember my suggestion, if you get a subtraction, change it to a plus and change the sign in front of everything on the one that you're subtracting. Okay? Not the top one, just the one you're subtracting. So this was positive 3x, it became negative. This was plus 3, it became minus 3. Okay? 3x minus 3x is nothing. 5 minus 3 is 2. Okay? That means we can rewrite this as 2 over x plus 1 plus 3. Okay, this is our remainder, so it goes over the top. Now this looks like something we're used to, right? This is a shift 1 to the left and up 3, and then it has a stretch of 2. So let's do our new asymptotes. 1 to the left would be right there. Look, I don't know if you can see him. There's a little fly on my whiteboard. He was cute. And then up 3. Okay, so there's our new origin. Now we're going to take our a equals 2. So we're going to take all these numbers, multiply the y values by 2. So instead of over a half up 2, from the new origin, I'm going to go over half up 4. And then instead of 1, 1, I'm going to go over 1 up 2, and over 2 up 1. Okay, notice I did all those moves from the new origin, not from the original one, not from 0, 0. I went from there. And then same thing here, negative 1, negative 2, negative 2, negative 1, and negative 1/2, negative 4. There's my graph. Okay, so division is a good way to rewrite these so that they're in the correct form, so it's really easy to see the transformations. Okay, let's try a couple more. The rest of these, just to keep the video a little shorter, I might not graph. Maybe I'll graph this one, and then the rest of them I'll let you graph. We'll just rewrite them. Okay, let's try this one. Y equals 2x plus 3 over x minus 2. Okay, so we're going to do x minus 2 goes into 2x plus 3. How many times does x go into 2x? 2 times. Then I'm going to multiply, so 2 times x is 2x, 2 times negative 2 is negative 4, and then I subtract, and since I'm subtracting, I'm going to change that to a plus and change the sign in front of everything on the second one. So this was positive 2x, I'm going to make it minus 2x. This was minus 4, I'm going to make it plus 4. 2x minus 2x is nothing, 3 plus 4 is 7. So my new equation is 7 over x minus 2 plus 2. Okay? That means my asymptote moves 2 to the right, and my other asymptote moves up 2. And then I have a stretch of 7, so I'm going to multiply all the y values by 7. So over 1/2 up 14 is going to be off, I think, 2, 4, 6, 8, 10, 20, yeah, just barely off the board. And then over 1 up 7, remember I start from my new origin, over 1 up 2, 3, 4, 5, 6, 7, and then over 2, half of 7 is 3.5. Right there. Okay, I always try to keep these even. if that makes sense. And then -1, -7, so 2, 3, 4, 5, 6, 7. -1/2, -14, 8, 9, 10, 11, 12, 13, 14. And then -2 and -3.5. So there's my other half. Okay, so that's polynomial division. Like I said, they're almost always nice, easy ones where it's just an x on the bottom, so they're not too bad. Okay, I will show you how to do inspection, and then you guys can try them on your own. Alright, inspection, like I said, it takes a little bit of getting used to, but once you get the hang of it, it's not too tough, okay? I would want you to try both of them. After you've tried them both, just pick whichever one you like the most. It doesn't really matter which one you use as long as you can rewrite them. Okay, inspection, the idea behind inspection is we want to rewrite the top so that we can cancel an x plus 1 out of it. Okay, so what we're looking for is what number can we add here so that we'll be able to cancel the x plus 1's out, okay? So I factored a 3 out. If I redistributed this 3, and notice this part I just made it match there. If I distribute this, I would get 3x plus 3 plus whatever this number is, okay? And we want that to equal 3x plus 5. Okay, well there's a 3x on each side, so we could do minus 3x, minus 3x. You can probably figure out what that question mark is supposed to be, but just in case we'll do minus 3. So we get that the question mark is equal to 2. Okay? So, I rewrite it like that. When you get the hang of this, you can probably almost do this part in your head. You won't have to write it out. But don't be embarrassed to write it out, okay? So the key there, whatever this number is, you're going to factor out. And then you want the stuff in the parentheses to match the bottom, for a reason we'll see in a minute. So then you need to figure out what this number is, so that if you distribute this and add that back in, your answer will be 5, okay? Once we do that, we're going to rewrite this as 2 fractions. Okay? So we basically just took the numerator, the top, and split it into 2. We can do that because if we were going to do like 3 over 4, we could rewrite that as 2 plus 1 over 4, which we could then rewrite as 2 over 4 plus 1 over 4. All 3 of those are equal to each other. So it's perfectly acceptable to split those in 2 as long as we're adding. Okay? Once we do that, if you look at this side, the x plus 1's cancel out. So we have 3 plus 2 over x plus 1. And then I'm going to rewrite that a little bit so that it looks like that. Okay, that is the same one that we did with division. Okay, so you would shift the asymptote 1 to the left, you would shift the other one up 3, and then you'd multiply all the y values by 2. Okay, let's try inspection on this one. Okay, I know I'm going to have a 4 on the top and an x minus 2. So I just need to figure out what is this number so that when I distribute I get negative 11. Well, if I distribute this, I would get 4x minus 8 plus whatever this number is, and it's going to have to equal 4x minus 11. Okay, there's the 4x's kind of cancel. I could do plus 8 on each side, and I get that the question mark is negative 3. Okay, so I'm going to make that a minus 3. Okay, that's a little confusing, I know, but once you try a few, you kind of get the hang of it. It's not that bad. Let's split this up now. Oops, minus 3. Actually, I'm going to make it plus negative 3 over x minus 2. Okay, these will cancel. You're going to want to, because you guys are kind of lazy, skip this step. But I would caution you not to do that because I'm worried that it will kind of mess you up. Okay, now we're almost done. I'm just going to switch these two so I get negative 3 over x minus 2 plus 4. Okay, this has a shift 2 to the right and up 4, and then you would multiply all the y values by negative 3 if you wanted to graph it. Alright, I will do one more for inspection and then I'll turn you guys loose to give these a try. Alright, let's try this one. Y equals 2x plus 1 over x minus 3. Okay, I want to rewrite the top. I know I'm going to factor a 2 out. And I want x minus 3 in the parentheses. And then I need to figure out what number do I add there so that when I distribute I get 2x plus 1. So I'm going to distribute the 2. I get 2x minus 6 plus whatever this number is, and that has to equal 2x plus 1. Okay, well the 2x's kind of cancel out. If I do plus 6 on each side, I get that the question mark is 7. So I'm going to change that to a 7. Okay, then I'll split it in 2. Okay, these cancel out. And then I'll switch them just so it's in the same order I'm used to. So this has a shift 3 to the right, up 2, and we would multiply all the y values by 7. Okay, that is inspection. So you should theoretically know how to graph just a regular rational function, and then you have two different ways of rewriting them if they're like that. Okay, you can use whichever method you want. Okay, for your comprehension checks this week, you're going to have 2 graphs, and I will give you a hint. They're both going to be ones you have to rewrite. Okay, you'll need to show all your work, and the other thing I'm going to do is when you guys are done, you can email them to me. And I'm just going to save them all till the end of the week and grade them all at once, because what ended up happening last week is like every half hour I was getting an email, and then I would respond to it, and then I'd go check it, and it was just super time consuming for me. So I will grade them. I might grade them like in 2 chunks or something. But so just like last time, when you're done with the practice problems I give you, you let me know when you're ready, and I will send you your comprehension check. And when you're done, email it back. If you email it back and I don't respond, that's fine. Okay, don't freak out. I will grade it at some point. Okay, so once again, no school the rest of the year, so make sure you're doing the work. It's an easy way to pass Algebra 2. I can't begin to explain how easy you guys have it if you do the work. Okay, and then make sure everybody else in the class is doing it too. There was about 2/3 of you guys ended up doing the homework the first week. We need that to be closer to 100%. Okay, you guys are Algebra 2 students, so you need to do better. Okay, I expect more from you guys. Other than that, I miss you guys. Remember Zoom chat Tuesday, Thursday from 10 to 11, Friday evening 8 to 9. If none of those times work, email me and we'll set up some other time. So I would love to see some of you guys in there instead of just Alan. I mean, it was nice seeing Alan, but it'd be nice to see more than one of you. So talk to you guys later. Good luck.